Well, the time has come again, yet again, once again. Boys and girls, we have ourselves a turd, and we're going to polish it and make it into something different. This is a legit Sweet 16 fan kit from back in the day. Isn't she a beauty? Can you see the diamond in the rough here? I can. First off, let's cut that. And we're going to cut all of this. And cut this too. We're going to held together with an electrical tape plug. We're going to pull that out. We're going to file that in the appropriate department over there. Get rid of the electrical tape shoved in the fuse holder. Now, I don't know exactly electrically what this ground that they've attached to the front does, since it's held in place by a rubber insert. But I'll pull that screw out. I don't think this was actually doing anything other than just being shoved in the fins. So we're going to look around the dirt. We're going to look around the dust. And I want to show you why this turd is worth polishing into a diamond. And the case is good. I don't like these fans, but I have a plan. Leave it up to me. I got a plan. Let's pull the bottom / top piece off first. We'll set it aside. We'll come back to you. This heat sink is disgusting. That's fine. We're going to come back to it. So you can tell that's a factory punched fan kit. And this thing was designed to sit on its side in the day, like this. That's not the way it's going to leave here, though. We have better technology at our disposal now. But the reason that this gem, this turd, needs to be polished is because it's full of real deal, old school, stock Toshiba 2879 non-red dots. So I think this justifies a full rebuild, a cleaning, and then I think it needs to go find a new home. Not here. So let's just start here, and we're going to slowly suck in the beauty of this dirt ball. It's got 8 Toshibas in it. Okay. It's been rebuilt. And the bias circuit has been fully removed. We've got this thing going on for the fan circuit. This tells me it's been unplugged a couple times the wrong way. It's because they bypassed the fuse link that goes here. So somebody's unplugged the fan and blew the trace. We've seen this before. We can fix all of this stuff. The output combiners are straight out of a messenger someplace. And this kind of scares me a little bit. The $6 million question is, does it work? I don't know. The 1.8 ohm resistors have all been removed. All the way across. I got this going on down here. All the biasing has been removed. The filter caps, all that stuff's been removed. I can add all that back. That's not that big of a deal. The question is, do the transistors work? So, we'll put that there. So this meter is 1,000 in average, or 1,000 in PEP, 1,000 in average, and 5 watt in reverse back from the bird, 10,000 watt dummy load. We're on 12 volts DC at the moment. Amplifier's off. Hello, 1, 2. Hello, 1, 2. Amp does work. Hello. Oh, it's going to get with it. Look at that. Some transistors are working. Those transistors are working. Those transistors are working. Those transistors are working. Hello. Hello. No imbalance there, but I got an imbalance going on here someplace. Hello. But it is transmitting in fine style. So that's with 20 watts of drive. All right. Let's hit it with some 490 action here. SR 490 with a 2879 Toshiba transistor in the back of it on 12 volts. Let's try this again. Okay. Turn that radio on, turn this radio off, grab this microphone. Hello, audio. About 120 watts worth of drive on the 490 on 12 volts. Hello, audio. 1,000 watts. Hello, audio. Hello, audio. 1, 2. Yeah. Hello. So we got some problems. Let's see, how hot is this resistor now? It's not too bad. Certain input tune like. Hello. Oh, wrong microphone. 490. Ooh. Hello. 2 watts of input reflag. Okay. Let's see, what are we pulling for amperage? Hello, audio. Hello, audio. So we've seen 100 watts of increased power out of it with 100 watts more drive. That's not linear. All right, so we'll bring our voltage up. Our 15-ish volts. Hello. Of course, it's in the corner. Take that up to 2x now. Hello, audio. Hello, audio. Okay, so it's making stock power. It's making 1,600 watts peak with 120 watts of drive. There's a huge difference in performance between 12 volts and 15 volts. Would you agree? Okay, well, it's working. We'll give it that. The question is, if I take my fingers and I slowly run through this cabinet, can I make it work better? And can I restore it to its former glory? First off, these power wires got to come out of it. Gone. Second thing, it's got to have a bath. I will appreciate this. This will tell you that somebody out there realized what I preach to the choir all the time is something that needed to happen a long time ago. All the fuse holders have been bypassed. With a little tiny piece of 22 gauge wire. So this is the always and always will be the weakest link in the box. Those fuse holders in the amp. Yeah. All right, let me grab my cell phone. We're going to do a top-down picture of this, then we're going to give it a bath, and we're going to pull the wires out of it, and then give it a bath. And I want you to see just the before and after by just giving it a bath. Whew. She's a dirty girl. Dirty girl. Consider that a victory and a half since I don't have one of those switches. So here's the deal. That's the sideband switch out of this amp. It was completely lock frozen. I'm like, what the hell? So I go and I take the switch apart, and inside the switch, this center pin, somebody had soldered to it so hard that it had slid back out of the plastic. Well, we heated it up a little bit and slid it back in, but this thing had gotten so hot that the heat had transferred to the metal plate that rocks back and forth between these two contacts. And when it did that, the solid plastic pin that sits in here, there's an output shaft that hangs off the back of the switch, and inside that shaft is a spring, and then on the end of that sits a little plastic nylon tip roller. So you have your rocker plate, a switch that sits on top of it. So you flick the switch this direction and it makes contact with the center post, and then this contact. Flip the switch this direction and it makes contact with the center post and that peg. This lead had gotten so hot that the heat had transferred through, got the plate hot, and then that in turn had transferred over to that little nylon post. That little nylon post was disintegrated. So the switch was stuck in the off position. I took it apart and just built me a new nylon post. Honestly. Yeah, we got this all working now. It works just as smooth as glass. It just took a couple minutes. I took a little hunk of nylon that I had, chucked it up in the drill, got out the jeweler's file, spun the drill, made a nice little round tip, made it so it had a shoulder on it so the spring would sit on it, and threw it in there. It took maybe 5 minutes. But yeah, you guys are not going to believe what this thing looks like now. That's that same brown turd bucket of an amp. I mean, it was foogly. Foogly. Now it's all clean. Look at this. Oh yeah. Oh yeah. Oh yeah. Heatsink is spotless. Spotless. Inside of this thing, spotless. Faceplate's all cleaned up. Ass end of it, all cleaned up. Spotless. Okay, so now we're going to continue forward. First thing we got to do is we got to rebuild the bias circuit in this. I've had a guy that has been calling me once a week for over a year and a half, wanting to know if I've got this for sale. Dude, you got one for sale yet? No. Dude, you got one for sale? No. Dude, you got one for sale? No. Tired of telling him no. So I finally get to tell him yes. So what we got to do is we got to replace this filter cap that sits here. We've got to add a resistor that goes from here to here. Let's just move these up out of the way for the next little while, since that's all we're going to do. Let me zoom in here and explain to you what's going to happen. We've got to take it out of Class C. We're going to move this over to this trace. We got our coupling diode. There's a 1.8 ohm resistor that goes from here to ground, and then we've got a resistor that goes from here to this lead. We have to add that. Then from here to this lead or any other associated trace, we've got to add a filtering cap. Does it really need to be there? I won't say it's life and death. I will say that it helps just a little bit with keeping the bias voltage a little bit more stable, at least in this design. I do the same thing here. Take this out of Class C, reattach it here. Got to put a coupling diode across here, or a capacitor. Pardon me, it's a capacitor, not a diode. Sorry, I said that was a diode. It's a capacitor. Put a couple nanohenry capacitor across here, or not nanohenry. A couple picofarad capacitor across here to ground. Add the resistor. Add a wire from here to here, and then add a capacitor here. We're going to repair this trace, which is like the most commonly massacred trace in the whole amplifier. All these amplifiers. We got to do that for all 4 boards. Then when we're done with that, we can come and address this issue. Technically, it's the right material make. Technically, it's the right number of turns. I just don't like how it looks. Nor do I like how this looks. I don't like how the resistors are set up, so we're going to change that. So we're going to do a little bit of repair work here. And then when we're done with that, and we get all this tested and certified. Okay, 4 new resistors, here, here, and here. And the new resistor's here. New resistor here, new resistor here. Clean that up. Clean this up. And we test all of that. And we're going to come back over here and we're going to repair this gobbledygook. We're going to take this fuse holder and we're going to go from this position to this position with it. So this is no longer used for the fans, which is good. We're going to pull it out, but we're going to use this holder. We're going to flip it around and we're going to attach it over here to the switch. And then we're going to appropriately extend this white wire, attach it to the fuse holder. So that way, when you flip the switch on, click on position, run. Run, it says, run. And somebody decides to be a jackhole, and they just want to screw with you and shut you up for the night, and they decide when you're showing them your amp, you unplug the fan, it'll just pop the fuse. It won't massacre the trace, which will permanently disable the amp. That's what's happened here with this bullshit mod that's taken place. It backs up through the switch, and it goes to the next weakest link. After this trace pops, and it goes to a trace underneath the board, which is a bigger pain in the ass to repair. Or you can just take a wire and go from here to here, or from here up to here. Okay, I digress. We're going to replace the coax connectors with brand new actual Teflon. Not $1.99 Teflon, but legit Teflon. You can get on Amazon and you can order for $1 and like 12 cents, you can get a Teflon, quote Teflon, come to find out it's just nylon. You can get yourself a Teflon / wannabe gold pin that as soon as you go to solder to it, the gold pin will fall out of it. Connector, these are better. This is a real deal. It's legit silver. And just by me touching it with my fingers, it's going to be black within 6 months. We're going to replace these old plastic wannabe Bakelite connectors, which have worked well for decades, and most of the time I don't replace them, but these have been so severely burned from whenever this amplifier had been thoroughly scorched down, and this combiner went up in smoke. This is the right combiner. I do believe it is the right material makeup. Once again, I don't like how it looks, so we're probably going to change that. We're definitely going to change these. I think we're going to go to like a 2-to-1 setup on this deal on the output side. Make it just a little different. We'll use type 61 there to make sure it's good and clean harmonic wise. And we'll readjust the output tune a little bit. Then we're going to do the power distribution. So that means we're going to go over here and we're going to put body plugs in here, put a grommet here, bring the ground in, attach it here, like we do on all of them. We'll bring in the 4 gauge, we'll wrap it around, and we'll do curly Q up into your hair. Okay, got it. So, first thing, we're going to do the bias circuit. Well, let's give you a quick little situation update here. So, this has all got the bias unmessed up. Brand new cap in here. All got the bias reinstalled. Brand new cap, brand new diode, brand new resistor. Same thing here, same thing here. And then I rebuilt the combiners so they were tight. Rebuilt this combiner over here so it was tight, or here so it was tight. Redid the output combiner circuit, put the brand new coax connectors on it, cleaned all of that up, changed out this resistor to a 5-watt, made it so it was balanced. Changed out all the straining leafs on the back. So this is all done up. New plugs to replace the old rotten fuse holders. Put 4 gauge directly into the box, which I don't care who you are, that's a huge increase. Changed the fan plug, so we took the fuse off of here and repurposed it to here, so if there is a short of some kind back here at the on-off plug, it'll pop this fuse, bink, and it protects this trace. We rebuilt that trace appropriately, which means I got in here, I cleaned all the solder off of everything, then I took a razor blade and I cut the trace off nice and square, did it here, and then I relayed down a new piece of trace tape and repaired this trace thoroughly. I replaced all the jumpers up here in the front with Teflon wire, replaced all the wire going back here with Teflon. Everything in here now is Teflon. because a lot of this was rubber. Down here on the bias circuit, replaced all of this wire with Teflon because it did have rubber wire in its place. So this green wire here and this here and this here is all new Teflon wire. This thing is coming right along. The only thing I have left to do now is to add the 12 volt distribution from here to here, here to here, here to here, and here to here. And we should be good to go. Added nice new long brand new power wires to it. I think we're in top shape. All right, let's get the power wires in it and then we can move on and start totally dinking around with the fans. So it's all done. All the power distribution's in. Now we're going to run the same test as we did yesterday. Well, from your point of view in the previous segment. Let's turn the amp off. We've got the Striker 490 running into this thing. Put this down on 1X. Hello, audio. Same amount of drive as yesterday. 180-ish watts. Put it up in 2X. Hello, and 2. Okay. So we're showing that the meter is linear. Otherwise, we go from one multiplier to the next, we're seeing the same thing. So now we're in 2X, so that needle moves full all the way to the right. It's 2,000 watts. If we see one more watt than what we were seeing yesterday, that tells us that this thing is working better. Oh, hold on, I gotta take this call. Okay, with the same radio hitting this thing, we see one more watt over 1600-ish. We've made the amplifier work more efficiently, use less current, blah, blah, blah. So here we go. We're wanting to go past the 80 mark. If we get anything past 80, anything past 80 is an improvement. Hello. Every time, I'm telling you, power wire upgrades are a thing. Okay. Hello. It's making 1900 watts almost of power. I'd say 850. Hello. Hello. 1700 on the outside. Hello. Audio. We'll call that a conservative 1700 watts of power. So simply changing out the power wires and reconnecting the bias, changing the splitters around a little bit, we picked up another 100 and some watts to 200 some watts out of the amp. Hello, audio. Hello, audio. I dig it. I dig it. Well, hello. I dig it. Okay, last step out of everything. Let's go see if we can take this fan kit that we got over here and let's see if we can make it really, 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 really pretty. Okay. Note to self, insert clip of old cabinet here. I want you guys to slowly take this in. Now, I'm not completely done with them. All right, let's come back to the workbench. I'm not completely done with them, but I have massaged those old cabinets into this. Them old fans that you needed a tetanus shot to look at. These little noisy hoppers, they're gone. Okay. Now, I went and I manufactured standoff legs and added guards, but I manufactured these legs out of other brackets I had sitting here. These are completely handcrafted feet for the stand. Here's the lid. God, I hope you guys are ready for this. This is really pretty. Inside. Or not lid, this would be the heatsink side. So this will be the top. That's the lid, which is technically the bottom. I know, the name is confusing, right? But think about it. I took something very old and beat down, broken, abused, and we turned it into something very pretty and nice looking and way more functional. So $60 worth of fans, $20 worth of brackets later, about $10 worth of hardware and a good plug, some heat shrink and some solder and the ability to twist wire, and we're going to be finished. But I want you to think back to how fugly this was when we started. And I've got the Anderson clip. I've yet to do it. It's going to get an Anderson clip on it too. But this is by far one of the dirtiest. Well, I got amplifier number 1 over there that's way dirtier than this. But this should give everybody in the radio world hope. If I can take something that's that nasty and turn it into something this nice. The only thing I don't like is how the short vent, there's not a lot of air exhaust. Now, the newer fan kits, they've got slots down both sides and it's less air restriction, but we're going to have to get away with using the air slots here and the air slots all down the side of the cabinet. I think we're going to be fine. I think everybody's going to be okay. I think Mary, Tom, Susan, and everybody else involved in this game is going to be okay. So, let me wrap this up. I just wanted to give you a little status update. I mean, that is sexy to me. And it's completely handcrafted. It's not like it was, here, I ordered these from CB Distributing and I'm just going to put your tins on. No, I handmade these things out of beat up, disgusting brown garbage. These things were both completely brown, gross. And I took and washed them by hand, scrubbed them by hand. Then I went through and I wire brushed the inside of the cabinet so there was zero rust underneath this paint. I primer coated this and then I repainted this. I made the stands. I punched out and upgraded and made the holes bigger, put brand new fans on here. Better than what you would buy if you were to spend the $180 for the fan kit that went on this thing. These Sun-On fans whoop dog ass on the fans that come on the new kits. Let's bring this the rest of the way home. All I'm going to say is this turned out better than I thought it ever could. And thank you guys for following along with me on this rebuild. I'm tickled with how this turned out. I'm absolutely not going to lie. As I was putting the fans on it and I was putting the last little kisses of love to this damn thing, I was like, damn it. It turned out beautiful. I cannot believe that is the same fuzz bucket brown turd that came in here earlier today. Gentlemen, my name is BBI, and I'll see you all. Goodbye.